Okay, so let's look at integrating a question where it looks like a bunch of complicated things in your exam, but if you just look at them all individually, you're going to be fine. And most of them, there's just a solution at the bottom. So when you go down to your formula sheet, you just got to match it up. Okay, so the first one, we see it's something to the power of something x. So we notice that there's an x in the exponent. So we go down to our integrals and find where's there an x in the exponent, and we find it here. Okay, and so that's the green bit there. And so when we want to integrate this, we simply put whatever is here over here. So if I look at that a, which is the base of the exponent, that would be this bit here. Now, as I explained to you from your exponent laws, if I have 2 to the minus 9 to the power of x, when I have an exponent to the power of another exponent there, we multiply them together. So we end up having 2 to the minus 9x. Which is essentially what we have in the question, 2 to the minus 9x. So we can think of the 2 to the minus 9 as the a. So that's the trick there. Don't think of it as 2. Don't think of the a as 2. Think of it as the a as 2 to the minus 9. And so that we've allocated the color pink to. So that's there and there. And then, as I explained to you now as well, when you have, say, a k f of x, where f of x is a function, say, it's sort of something that we want to maybe integrate. Where k is just a number, like 2 or 3 or a half, we can actually, the k just comes along for the right. So we could actually write it as k, the integral of f of x. So we'll see how that works here, because if we see that the k, let's allocate k purple, k just comes along to the right. It's at the top, so it's timesing, and it's still timesing. So it's really doesn't get involved other than just coming along for the right. If you end up with an answer of, say, 2 times a half, where k is the 2, you can times the k in to get 1, right? So 2 times a half is 1. But other than that, so even if we look along here, this half in front of the cosec squared x, that's just the k. So that's going to come along for the right. There's 15 in front of the sign, that's going to come along for the right. So we'll see, we'll just allocate k as purple for all of these questions, and we'll see that don't worry too much about a number in front of the function, because that's just going to just be there at the end. So I just now write this in. So my k, which came along for the right, is actually 1. So I don't have to write anything, because 1 times 3 is still 3. So I'm just going to write the pink in here. So the pink bit there, I don't think I need, let me do it here at the bottom. I'm going to do it here at the bottom. We're going to do everything in one line. So we have 2 to the minus 9. Oh, well, we're actually not going to do it in one line. It'll be 2 for this one. 2 to the minus 9 is the pink. And then x remains there. And then I notice I've got the pink at the bottom, right? The 2 to the minus 9. And then I have ln, and then it's a to the x. So the x is the green bit. And you see how I've done that there. And I'm going to write it there, even though it's not going to stay there, but it's just a 1 here, 1 times. That's the k, which doesn't change anything. Now, in your memo, you'll notice that the answer is 2 to the minus 9x over minus 9 ln 2. And that's because of our log laws, which says the minus 9 goes to the front. And so that actually simplifies to k to the minus 9x over minus 9 ln 2. Now, if you had seen, so there should be a 2 here, and k goes away. If you had seen a different answer, if you had seen the 2 at the bottom, so if you'd seen minus 2 to the 9x times 9 ln 2, 1 over, that's okay. All they're doing is they're using the exponent laws of saying, well, x to the minus 1 is the same as saying 1 over x. So they would essentially be taking 2 to the minus 9x and saying, well, because it's minus, I can take it to the bottom and make it 2 to the plus 9x. So sometimes you may see the memo with removing taking the negative exponents and moving to the bottom to become positive. Okay, so that rule here, x to the minus 1 is 1 over x. We just got to remember that. The cosec squared x, let's look for it in our formula sheet. Here it is. Now, this doesn't have the integral sign, but remember the derivative goes this way, right? So we know that y, the notation for derivative is dy over dx, or y dash. So every time you want to find the derivative, you go this way. Derivative goes this way. Okay, and integration is the opposite of a derivative. So you must know that the integral goes this way. So if you ask to find the integral, I'm just going to do this in a different color. Just look on the right-hand side, and I don't know if you're still there, if the load shedding has kicked in yet. Integral goes that way. So we're looking and we're saying, okay, there's a cos squared x. Highlight this in light blue. And there it is there. So it's just going to become cot. But it's not a minus, it's a plus, right? Because minus cosec squared x is cot, which means cosec squared x must be minus cot. And of course, the k comes along for the right. So here's another example where we see k, the thing in purple, which is in front, just comes along for the right. So we have minus a half and a right here, so that we keep track of what we've done. So the blue, the light blue is the cot x. Okay, now the next one is pi over x. So we're looking now. What's confusing here is that the pi, people go, what is the pi? But pi we know is actually just a number. Right, so pi is 3.14. And so we can say, okay, it's actually just a number. So let's say it was a 3. Well, that's fine. It's just a number. So it's like, so a. So when we look, we see, okay, it's a number like a, because a represents a number over x. So essentially this one, it's highlighted in green. So the pi is over here. Oh, so I also had load shedding. Are you still there? Okay. Okay, so I'm at my grandfather's house. So I didn't realize I also had load shedding. I've just put it on a hotspot. Okay, so where were we? We were at we were looking at this one, and we're at pi over x. So I'm just gonna we've done these ones, so I'm not gonna do those. So minus pi over x plus x to the minus 7 over 5 minus 15 sec 15x tan 15x plus ln y. Okay, so with these questions, we can look at the formula sheet and we know that going this way, we find the derivative. So this way is the derivative. So when they say differentiate, and then the other way is the integral. Okay, so this formula sheet, all of the things that you think are pretty tricky, are actually not. We just have to look at the formula sheet. So we were dealing with pi. Now pi is just a number, like it's 3.14. So it's actually just a number. So we can think of it as a number, like a and over there, and then the x is on the bottom. It's gonna move this slightly more down. I don't need to do. There's no one with a to the x. Okay. So I've highlighted the a in purple. And then the x is just this thing over here in orange. And so all I do is I literally just plug it in from the formula. It's actually so nice and easy. It's minus pi ln the orange thing, minus pi ln the orange thing, which is x. Okay, so that's that done. Now this one here, even though the exponent is a fraction, it's actually just our regular rule, which says we add 1 to the exponent, so n plus 1. So this is the most confusing formula to look at, but actually we just need to think of it practically like we always do, which is we add 1 to the exponent and we divide by the new exponent. So that's what the n means. So you notice x to the power of n. A is the thing that just comes along for the right. There's no a in this one. A is 1, which you don't have to worry about. And then it's n plus 1. So we add 1 to the 7 over 5, and we divide by the whatever's going to be the new exponent. So we have, so this one's there. I'm going to do this over here, because you can integrate each thing individually. So minus 7 over 5, and I just add 1 to the exponent, and then I divide by the new exponent. So I'm essentially dividing by minus 7 over 5 plus 1. So we end up with x minus 7 over 5 plus 1 becomes minus 2 over 5 over minus 2 over 5. Now, in the memo, they could have x to the minus 2 over 5, or they could have x to the 2/5 at the bottom. So in other words, moving the minus 2/5 to the bottom to become positive. And then the minus 2/5 is essentially saying minus 2/5 at the bottom is the same as saying 5/2. In other words, let's think about minus a half. Well, sorry, let's think about 1 over minus a half. Well, that's just saying 1 divided by a half is 2, so we end up having minus 2. So essentially the half gets flipped to 2/1. So let me just go one more example. 1/5/7 is the same as saying minus 7/5. Okay. So you can even put this in your fraction calculator to see how that works. And so that's the answer for the one, 5/2, x to the 2/5. Then this one, sec 15 tan, looks all suddenly very confusing. This is an x, yes, 15x and tan 15x. It's not, it's right in the formula sheet. So if I highlight that in yellow, in light blue, it's over here and over here. And all we have to do, the 15, remember 15 is like the k, it just comes along for the right. And so that just goes to sec x. So for that one, for this one, it's just minus 15 sec x. Sorry, sec 15x. And then the last one, ln y, is not on the formula sheet. You just have to know that the derivative of 3, the integral of 3 is 3x. And the reason for that is we can think of it as saying 3x to the power of 0, because anything to the power of 0 is 1. And so if we were to add 1 to 0, we would get 1. And then we would divide by 1. And so we'd just end up with 3x. That's the maths behind it. But literally all you have to think of is if it doesn't have an x, just put it. The integral is just whatever it is, x. So ln y, the derivative is just 15. Is just ln, or I'm just going to say x ln y. Okay. It's essentially ln y times x, but I don't want to write ln yx because then it just looks like ln yx. Yx is part of the ln y, which it's not. It's x times ln y. Okay, so that's in light green. Let's highlight that. So I didn't have a lot of sort of space to kind of write stuff down. Hopefully you followed. You can watch the video again to see. We did each integral individually. Okay, so you are asked to find the integral, so they'll stick like that, of each of these. And we found this one over here was this rule here, right? In purple and green, purple and orange. The light blue, that was this rule here. And so you just need to look at the formula sheet and see where are my answers. And in this one, I explained to you what happened there. This law here, this is the most common rule, and it's the most confusing formula. Right? It's also the most confusing arrow ever, but it's this one here. So yeah, we just want to think of that rule as we almost don't want to look at the formula because the formula confuses us. Just think of if it's x to the 6, you just add 1 to the 6 and divide by whatever you've added, whatever you got the exponent became, which is a 7. So the integral of that is that. Okay, so yeah, basically the takeaway from that is that it's not as difficult as you think. It's just, you just got to go down to the formula sheet and find the answers. Okay, so that should be fine. I'll just stop recording there. I hope it's okay with all the load shedding.